The next topic we're going to look at in IP services is our network address translation, or NAT config, which, as we know, is used to rewrite the IP addresses in the layer 3 packet header for either IP version 4 or IP version 6. Now, typically this is used to change the source addresses of packets, where we're trying to hide our private addresses, like the RFC 1918 space in IP version 4, from public destinations on the rest of the network. But it could also be used for overlapping subnet issues, where maybe one network acquires another one, and they're both using the 192.168.0.0/24 subnet. To get communication between the two of them, we would either have to renumber the networks or do some sort of translation, which in this case is called a double NAT translation, where we are translating not only the source addresses but the destination at the same time. So from one subnet that is 192.168.0.0, they're seeing the remote subnet as a different address, and then vice versa. This could also be used to change the destination addresses, either in that double NAT scenario for overlapping addresses, or when we are trying to allow access to our internal private services from the outside public network. Where, for example, we have our web server or mail server on a DMZ that's using internally private addressing, and we want to give them access to the outside network by mapping a public address to them. Typically, this is done with a static configuration, where we would say IPNAT inside source static or IPNAT source static, but technically we could do this dynamically, which could be used for TCP load distribution with NAT, where if we had multiple web servers that were mirrors of each other, we could simply use the NAT process to load balance between the servers. In most real applications of this, you would have a dedicated device to do the load balancing, but technically you could just use the NAT process on the routers in order to accomplish this. The other very common implementation with this is the port address translation, which is used for our overloading of many to one, where on the inside network we have more private addresses than we do have public addresses allocated on the outside. So we could either change the addresses to the interface address of the outside router or some sort of public pool that we are allocated. Now, part of the problem with the NAT configuration comes in from a confusion of how the terminology is used, the difference between the inside addresses and the outside addresses, and the global versus the local values. Now, the inside local and global addresses, those are used to denote the networks that we are trying to translate, where the inside local is what we are translating from, and inside global is what we are translating to. The key point being here that inside means that it's part of our own network, where local is the locally significant addressing, like the RFC 1918s, and global is going to be globally significant to everyone. So typically inside local is our private addresses, inside global is our public addresses. For the outside network, the outside global is the destination that we are trying to reach, and outside local is going to be used in a double NAT translation, which is the true address on the outside post translation. So in most NAT scenarios, you would only see inside local, inside global, and outside global. Outside local is going to be used when you're translating both sources and destinations at the same time. One of the important points to keep in mind with network address translation is that the order of operations is different whether traffic is moving from the inside of the network out or moving from the outside of the network in. Additionally, it's important to keep in mind that the NAT process is separate from the routing process. So just because I can translate the addresses doesn't necessarily mean that the destinations have a route back to the pool. Or just because I have a route to the destination doesn't necessarily mean that I have a translation. So they're two separate processes that need to be dealt with. The routing is always going to control where is the traffic going. Then the NAT rules are controlling how we are changing either the source addresses or the destination addresses in the layer 3 header. Where for traffic flows that are going from the inside out, First, we are going to route the packets, then we are going to translate their sources. Now, the idea behind this is that typically the destinations are globally significant, where those are referenced as the outside globals. So we pick what is the outgoing interface before we actually run into the translation rule. This would allow us to do separate translations on a per interface basis. And the design that this is typically useful for is if we have a router that has an inside segment that goes to the LAN, then multiple outside interfaces, where one of them goes to service provider 1 and another one goes to service provider 2. And router 1 does not have its own provider independent address space. So we're not running BGP, we just have a simple solution where we're doing default routing on both of the links. But the key is that if we are routing the traffic out to ISP1, I need to translate my sources. I need to translate my sources to the addresses that ISP1 has allocated me. So maybe this is pool A. Where if I go out this direction to ISP2, I need to translate to pool B, because I don't have my own provider independent address space. Now, configuration-wise in this type of implementation, this is where we would have separate NAT pools. Then the router is going to reference these based on a route map. So since the routing process is happening first, once the traffic gets to the NAT rule, the router will already know what is the outgoing interface, where we can tell the router to match based on what's the outgoing link, and then do the translation according to that. So you can actually get into really complicated rules with the NAT process, where you're doing this type of translation based on the outgoing link. You could also do the translation based on the particular destination. So we could do per port translations. Like if I'm going to TCP port 80, I could translate that way. Or if I'm going to port 25, I could go that way. Now, within the scope of the lab exam, you don't necessarily need to be an expert in the NAT process, just like any of these other IP services. So you'll see there are a lot of advanced examples of this in the Volume 1 workbook. As long as you try out a couple of them and know how to reference this in the documentation, then you should be fine. In our particular case, we're going to look at some examples of this on router 5, where we'll say that the link that is going to Fast Ethernet 0/0, this is going to be our inside network, and the frame relay is going to be our outside network. So the rest of the outside network, they're not going to have routing information to the devices on the inside. In order to get there, they're going to have to use the inside global addresses that router 5 has allocated. So whether this be a NAT pool that we're defining, or whether we are just overloading to an interface, we need to make sure that whatever sources router 5 translates to, the rest of the network has a route back to this. Documentation-wise, the NAT process is going to be under the IP addressing services. So under IP addressing services configuration guide, then network address translation. This second document, configuring NAT for IP address conservation, this is going to be the basic configurations of how we do the inside source translations. So again, those hosts are inside our network. We're trying to translate the source addresses from the locally significant values to the globally significant values. So the first thing I'm going to do here on the link between router 5 and switch 2, I'm going to change the addresses here so there's something that the rest of the network does not have a route to. I'll say IP address 10.0.0.5 on router 5. This will be /24. Then switch 2 on VLAN 58. The address is 10.0.0.8. Now again, the routing process is separate from the NAT process. So we need to make sure that the traffic can get from the inside out first through routing. Then it is going to be translated. So this would then now imply that switch 2 is going to have a route out to the rest of the network. I'll simply configure a default route to account for this. I'll say I'll default all traffic out to router 5. To test this, I could say on switch 2, I'll just ping the loopback address of router 5. If I can reach this, then I know the basic static routing process is working. If I look in the routing table for the dynamic routes, I'm not going to be learning anything in from 5 because I changed the address on the link to something that I do not have a network statement for under the EIGRP process. And I could tell this because as soon as I changed the address, the EIGRP adjacency was then going down. Which is fine though, because we're going to change the source addresses to something the rest of the network does have a route to. So now in router 5, the next step is going to be to define what is the addresses we are translating to and what is the specific NAT rule. The addresses we are translating to, they could either be defined by a pool or we could use some attached interface, whether it's the loopback or the outgoing interface. So I'll define the IPNAT pool. I'll say this is my inside global pool. The prefix will be 155.28.254.0 with a prefix length of 155.28.254.255 with a prefix length of 24. Now, what the net mask and prefix length match is essentially what address range the router is going to proxy for. So when now on the outside, someone sends an ARP request for any addresses that go from the .1 to the .254, router 5 is then going to proxy with its own MAC address. So if your prefix length doesn't actually match what you're trying to translate to, you're going to have a layer 3 to layer 2 resolution process when traffic is actually sent to the router. So now I know what are the addresses I'm translating to. Next, I need to specify the rule that says, how do I classify what traffic I actually want to translate? And this is where most of the problems come in with the NAT configuration, that if we translate too much traffic, so we are not specific enough in the classification, the NAT process can translate the locally generated control plane traffic from the router itself. Now, to demonstrate this on router 5, what I'm going to do is configure a BGP peering. I'll say this is BGP 5, and I'm going to peer with router 6. So I'll say neighbor 150.28.6.6, who is in AS 100. And they're an eBGP multi-hop here. On router 6, I'm going to peer with the frame relay interface of router 5, who's in AS5. They are an eBGP multi-hop here. So assuming that routing is working to begin with, I should have reachability to that destination. From router 5, if I ping 150.28.6.6, I am able to reach them. If we look at the show IPBGP summary, router 6 needs to say that its update source is loopback 0. We look at the show IPBGP summary. We see now we have the peering up to router 5. So router 5 is running TCP on the outside interface for the BGP session, and it's also running the EIGRP process. So two different control plane protocols I have now, EIGRP and BGP. So next step, I have my NAT pool already. If we show run include NAT. Next step is to figure out how am I going to classify the traffic that I want to translate. In this case, I'm simply going to say everything. I'll say access 1, permit any. Now I'm going to do the actual translation. I'll say IP NAT, and depending on the particular version that you're using, the newer versions get rid of the syntax that says inside and outside, because the direction on the interface doesn't matter anymore. Where previously you had to specify what's the IP NAT inside and what's the IP NAT outside interfaces. In the newer versions, you simply say IP NAT enable. So then you can define any translation that you want, regardless of what the direction is. So it makes it easier to translate from outside in versus inside out. We could technically use either syntax, it doesn't really matter. I'll simply say IP NAT source. IP NAT source, the source list is 1. So if traffic matches ACL1, which is anything, I'm going to translate to the pool, which I called the inside global. And I'll do a port translation. I'll say overload. Then the last step would be to configure the interfaces for the NAT process. So IP NAT enable at the link levels. Next on Router 5, let's look at the show IP NAT translations. And we should see that as traffic comes from the inside and then goes out, it's changed to the addresses of that pool that we've defined. So from switch 2, I'm going to send traffic to the, let's say, the loopback of router 1. On router 5, when we look at the show IP NAT translations, we should see that that traffic is changing its addresses to what I've defined in the pool. So let's show run include NAT. I have NAT on. It says that if the sources match list 1, where access list 1 is essentially everything, I'm going to change the source address in the packet to something that is inside this particular pool. So what's changed about this configuration now is that router 5 is not using a definition of inside and outside. But we should see here in the translation that the packets are being matched. So on router 5, let's look at the debug IP NAT detailed. And this should tell us whether the actual translation is occurring. So from switch 2, let's keep this ping going. Router 5 says it allocated a port for 10008. We translated it to 254.1. This is telling us that the packet was translated, so the source changed from 10008 to 155.28.254.1. It's really going to 150.28.1.1. So if we look at the show IP NAT translations, we should see this in here. We may need to say, let's say detailed, or show IP NAT translations. So we can see from the debug that the translation is actually occurring. If we were to go to router 1 and look at the debug IP ICMP, we see that the packets are coming in from 155.28.254.1. But if we look at the debug IP packet on router 1, router 1 says that for that particular destination, it's being routed out Ethernet 0/0, which essentially is the wrong link. So router 1 is getting the packets. If we look at the diagram, the traffic is coming from the inside network, inside network and going out, it gets to 1. When 1 is replying, the reply is actually going this way. So what this means is that there's a problem in the routing process, which again is separate from the NAT process. So just because I did the translation doesn't necessarily mean the destinations have a route back to the pool. So now what I need to do on router 5 is advertise that pool that I defined, 155.28.254.0/24. I basically need to advertise this into the EIGRP process. Now on router 5, if we look at the show IP interface brief, in the newer versions, there's a specific link that is called the NAT virtual interface, or NVI0, that's used to solve an order of operations problem with the routing process, where traffic is always sent to the NVI first before it is translated, which is why we don't necessarily need to specify what is inside versus outside. If we look at the show IP route, and let's say show IP route include 254, notice that the actual pool is not in the table, because the only place that it exists is internal to the NAT process on router 5. So there's a couple different ways that we could solve this problem. When we're defining the pool, which is the inside global pool, we could say add the route to the NAT virtual interface, which means that I'm going to have to disable this temporarily. So let's say show run include NAT. So I'll remove the translation. Dynamic mapping in use. I need to stop these pings is what it is. So you can see from the config it is sensitive to the order of operations. Probably what I need to do now to allow me to delete this is to remove the interfaces from the NAT process. So on the frame relay, I'll say no IP NAT enable, and then the same on the Ethernet. So I should now be able to delete the NAT rule. Dynamic mapping still in use. Let's try clear IP NAT translation star. Which now it allows me to remove it. So now what I want to say for the NAT pool, when I'm creating this, I want the router to automatically add a route. If we look at the show IP route connected, or let's say show IP route, does it show up as static? Yes, it does. So the router basically puts a route that goes to null 0, which is represented by the NAT virtual interface, which would now allow me to advertise the static route into IGP or to BGP. So in this particular case, since I'm running EIGRP as my routing protocol, I could go under the EIGRP process and say redistribute static, and I'll say any arbitrary metric. Now once I look at the rest of the network, if we were to look at router 1 and say show IP route 155.28.254.0, now I have an exact match for this via external EIGRP. So the key again is that the NAT process is separate from the routing process. You always need to make sure that you can get to the destination and the destination can get back. Otherwise, the translation is not going to matter. So one way to fix this is under the pools definition, you could say add route to the end of it, which is going to put a static route pointing to the NVI. Another way would just be to manually install the static route. So if I said IP route 155.28.254.0/24 is via null 0, then I could redistribute static into EIGRP. The third method would be to take a loopback interface and allocate it an address from the pool. As long as the prefix can get into the routing table, that's really the only thing that I care about. Now, if we look at the running configuration for the NAT process or static routing, notice that in the running config, it doesn't actually put the IP route statement. This is the replacement for it. So it's saying automatically add a static route for this specific prefix, which is /24, that points to the NAT virtual interface. But again, it's the same logic as saying IP route 155.28.254.0/24 is via null 0. Then I could say redistribute static. So whichever one we do, it doesn't really matter, as long as somehow we solve the routing process. Once I have the routing configured, now I can put the NAT rule back in, which is the source list. Then at the link level, say IPNAT enable on the serial and the frame relay. So from the internal network on switch 2, if I were to telnet to router 1's loopback, if we look at the show users, notice the source address is the post-translated address. So it's not the 10 network where the packet is actually coming from. It's the translated address of 155.28.254.1. So this configuration is going to allow traffic to go from the inside network out. But from the outside network, if I were to go to router 1, and let's say we telnet back to that address, the 254.1, since there's no translation rule that is specific to TCP port 23, router 5 is dropping this as the traffic comes inbound. So the NAT process could also be thought of as a security mechanism. It worked kind of like how the active firewall process of either CBAC or the zone-based policy firewall works, where unless the traffic was originated from the inside to begin with, which is creating the state information in the NAT table, then the router's not going to allow the traffic back in. So on router 5, if we look at the show IPNAT translations, we should be able to see the traffic being translated there. Let's see, show IPNAT. We have to say NVI translations. Okay, so this one is for the, when we say IPNAT enable, as opposed to IPNAT inside or IPNAT outside. So now this is essentially the inside source for the global address, so that's what we're translating to. This is what we translated from. But notice, see, we're going in both directions. We tried to translate that telnet session for router 1 on the outside, but we didn't actually know where to send it because no one had the previous translation to begin with. So for that application where you're trying to translate the destination, typically this is what a static entry is going to be for. So we'll say IPNAT source static. And we could also do this based on a port number for basically port forwarding through the NAT process. So let's now say on the outside interface for TCP port for the source local address, which is going to be the inside address. Here I'll say this is 10.0.0.8. They are going to listen at port 23. But on the outside, I'm going to have this be my interface address, the frame relay, and I'll listen at 1, 2, 3, 4, 5. So what this now essentially means is that if someone telnets to router 5's interface at port 12345, we're actually changing the, not traceroute, telnet to 155.28.05 at 12345. We're changing the destination address to what we specified here on router 5 as what the source is. So the syntax logic is kind of backwards because we're actually doing a destination translation. But since the router is putting this statically in the table, we can use it in either direction, either outside in or inside out. So this is a useful way here that you can get the router to listen at different port values for different applications. Where let's say that we don't want router 5 to listen at port 23 for telnet. We want it to listen to any other value. What we could do is essentially translate a local address. Let's say clear IP NAT translation star. So I need to disconnect this. So I'll exit. I need to say clear IP NAT NVI translations. So you see the syntax is a little bit different depending on which version you're using. The inside-outside format of the syntax or just the source and destination. So now let's say when someone telnets to port 8080, we want this to go to router 5's exec process. So I'll say IP NAT source static TCP. I'll send this to router 5's loopback at port 23. But I'm going to listen on my outside interface at 8080. So now when router 1 telnets to router 5 at 8080, this goes to, actually redirected to router 1. That should have said, yeah, that should have said 5.5. Which is kind of weird. I looped the traffic back to router 1 itself. So I need to say now clear IP NAT NVI translations. So that should say 5.5. Which then on the loopback I would need to enable the NAT process. So on loopback 0, let's say IP NAT enable. So for TCP traffic that is really going to my outside interface at 8080, it should be redirected to the loopback at port 23. Let's make sure that's the right address. 155.28.5.5. So it looks like 5 is not doing the translation. Let's look at the debug IP NAT detail. I want to see when router 1 sends this TCP packet, what is router 5 doing with it? It says the address came from 155.28.0.1 going to 155.28.0.5 at 8080. I changed the destination to 23, but then I changed the source to 254.1. So basically now this is an error in the classifier on router 5, which is kind of strange because even though the traffic is coming in the outside interface, which normally would be the outside interface, but again, it doesn't have it. There's no difference between inside and outside anymore, so we can translate in either direction. So essentially what the problem is now is that when we look at the, let's say, show run include NAT, this access list is now too broad for what the particular traffic is that I want to translate. So there's essentially an overlapping between what the static entry says and what the inside global translation I was trying to do was. So you'll see in some certain cases there's going to be a problem when the classifier is too broad. In other cases it's not going to make a difference. But to fix this problem in the first place, what you want to do is essentially when we say show access list 1, you should never say match everything in the NAT process. So if I want to match just the traffic that's coming from this segment, so the inside going out, what I should actually say in the access list is to match sources that come from 10.00/24 and translate those. So in the older syntax, it's usually not as much of a problem because there's a clear separation as to what is the inside interface versus the outside interface. Whereas in the newer NAT process, there's no difference between inside and outside. So you can do the translation in whatever direction that you want. So what I actually need to change here is on router 5, I'll say access list 1 permits the 10 network with an inverse mask of 24. Then if we show access list, IP access list standard 1, I'm going to remove sequence number 10. Then when we show IP NAT NVI translations, we should see now when we come from the outside in and debug IP NAT detailed. Now the translation is correct. So now it's going into the loopback of router 5. But it says can't create the entry. I may need to clear out the process now. So let's say show run include NAT. And show IP NAT NVI translations. It says the packet is coming from router 1 with the destination of the outside interface of router 5. It has been translated to the loopback, but it looks like router 1 is not getting the response back in now. So on router 1, let's look at the debug IP packet detail and see when it sends the telnet to 5, what is the response it gets back in? It is coming back at 8080. And then there's also a packet that's going to the loopback of router 1. This must be from... That's from the inside here.